Okay, maybe also Richard can do this. Then we are ready to go.
All right. So thanks, Thomas, for this introduction. Yeah, I'm very happy to be here again. This is another edition of a webinar that we already did last year. Is there any, maybe if you can just react with a thumbs up or in some way, if there's somebody who's already been here and listened to this webinar series last year, just to see if there's people who Thomas, yes. Is there anybody here who's never interacted with CernVM-FS before, hasn't heard of it at all? All right. So seems people are familiar with it, but it's also new, which is very good. So last time, this was actually done in collaboration with Kenneth, who gave a lot more details about EESSI. Now I'm the lead developer for the CernVM file system. I won't talk about EESSI too much. I will give you more technical details about CernVM-FS than you probably asked for. But for more of the easy related topics, I mean, feel free to ask anyway, because I mean we have Thomas, Richard here, and other people involved with easy, or ask on the Slack. I think there's lots of people who can answer more easy specific questions. One thing I also want to say: don't be shy with questions. I think there's different sections to this webinar today. I think I will also stop and ask if there any questions, but I'm actually happy if something is unclear that you can definitely jump in and ask a question directly. If that's coming in the next section, maybe I will point it out and postpone that. But all right, right. So let's get started then. So the agenda here, it's very roughly this. So I think I'll give a general introduction to the CernVM file system, why we actually came up with this, what problem it's trying to solve, then show it in the context of EESSI a bit, and then talk a little bit about the different ways that you would interact with it as kind of like configuring a client installation, configuring an actual repository, having it on large scale systems, the different things to note there. And then what I like to call further topics is kind of like really these alternative access mechanisms when you have trying to use CVMFS on a system with some limitations, monitoring CVMFS, troubleshooting CVMFS, and then also like touching a little bit about performance. And since we're developing CVMFS, I think I'll at the end have a brief slide also on future topics and plans that we have where we want to go next with the software. All right. I think I'll do a limited amounts of hands-on. I think I want to show you a bit of the internals of CVMFS while we're here, and probably won't do kind of like all of these setups as a hand-on directly. All right. So let's jump in and think about software distribution. So software distribution for scientific software tends to be a little bit different than for other types of software. If you think about the apps on your phone, if you think about applications on your desktop, where you typically use a packaging manager, it's a bit of a different sort of beast. Why is that? Because for once, so you have a cluster that updates and tries to get new software, right? So you publish a new version of your simulation software, and you have a cluster that is trying to want to get started on a simulation campaign, and all of this is then now trying to access software from a shared server, and this kind of like clustered access is really in the end a distributed denial of service attack on wherever server you actually serve the software from. Uh, for kind of like your desktop packages, right? You have staggered updates. I mean, users will update whenever they run the package upgrade commands. You have then it's not really done at the same time, and it also changes less often. Like right for scientific software, sometimes there's new versions coming in, and you want to kind of like be able to use them as quickly as possible. The next problem is the access pattern, right? So you have maybe a C++ application that has shared libraries, and it has dependencies, and it does then lookups for all of these shared libraries in different paths. So it's a very metadata heavy kind of access. So typically, anytime the type of network, the shared file system doesn't really cope well with these types of metadata heavy small files, anything like this tends to be kind of like not well adapted for any kind of these systems. I don't know if anybody knows the AFS, the Andrew file system. Yes, no. This is actually what's still being used at CERN to distribute the user home directories on shared login clusters, like interactive clusters. I'll actually show you this in a moment. And this initially was really was used also to distribute software for clusters, right? And it exactly had the problems that I just mentioned. And at one point, it just kind of like crashed and burned when there was too many applications accessing this, and then people were thinking about different ways of distributing software. And one more point is actually that for software, oftentimes you actually package more than you need, right? It's a tough problem. You have kind of like if you take a container image, which is a very bad offender in this way, like typically you have from a 1 GB image, you tend to use about 10%, 15% in the end when you just run one application. Of course, you can aggressively optimize also your container images so that you only have the stuff that you read, but that also comes with its own problems and it takes a lot of work. All right. So all of this kind of like motivated the development of the CernVM file system, which is a global read-only file system for software distribution. So we'll try to unpack a little bit what all of this means. In the end, the user experience for people using CVMFS is really a bit like using an on-demand streaming service, right? For your videos, for your music, you click on it, and you know that there's a big catalog that you can select from, and you just select this, and it is being streamed to your desktop workstation on demand, right? You don't have to download and keep all of the catalog at your local machine. So the user experience for CVMFS, if you're asking like how do I use CVMFS, it's just a POSIX file system, right? So you have kind of like really all of the typical accesses that you can do. Like the one very basic concept is that you have different software repositories. Sort of, there's a couple of terms that come up once and again, and I'll try to highlight those when they're a bit of a jargon. Like so, software.easy.io is kind of like one software repository. So it's one file system that you can mount that has software from Easy. And then when to use it, basically you can do directory listings, right? You can read the content, and when you do that, it gets just in time downloaded on the fly. So a few more technical things. It's a file system in user space with implemented via libviews. So it's fairly easy to install. If it's not possible to install Fuse clients, then there are some workarounds that I'll talk about a little bit later in this webinar. It's very optimized for distributing and storing software. And you might mean, okay, the software is also just files and it's just data, but it's data that has a very peculiar access pattern and a few properties that we tend to use to make it like really efficient. So one thing that we do is we have behind the scenes a content addressable storage. So you publish version 1.0 of your software, then you publish version 1.1 of your software, and maybe a header file doesn't get changed. Then this header file actually also doesn't really change on the backend storage because it's content addressed, like it is in Git. And that allows us to actually store software very efficiently. And in fact, it's so efficient that for a lot of experiments, actually just never delete anything from their repositories because they have enough storage. And in the end, it's a very nice property for them to have actually the full archive of all of the software there. So it uses plain HTTP transport to do this just-in-time download, which allows really for very efficient caching, and it makes it very easy to set up proxies and all of these different things. We can compress data, and we have a bunch of cryptographic security things that allow us to verify the actual content of the files that you're reading. So if you know Fuse, kind of like basically what this allows us to do is to implement in user space the action that should happen when you interact with a file on your Fuse file system, right? So there's a little bit of overhead associated to this because as you see here in this diagram, right, your application does a directory listing on mount, no, and then it does a syscall, right? It goes to the kernel, and then the Fuse kernel module kind of like bounces this back to user space, where there's the CVM-FS 2 process running, and this kind of like then tells the kernel what should be the directory contents of mount. So that this is basically then processed on the fly in user space. And what we basically do in CVM-FS is very simple. So if a file is already in the local cache that you're trying to access here, then we use this. We give the kernel back the file descriptor for this file. And if it's not in the local cache, we download it from our object store, place it in the local cache, and use that. So it's in the end a very simple concept. And the original deployment and the main use case for this was the data processing for the Large Hadron Collider. This was organized in what is called a computing grid. It evokes kind of like the simplicity of the electrical grid, right, where you just have your outlet, right? You plug in something and then you can use electricity, right? And here it was supposed to be so exactly as easy to get computing access, right, to across all of these different sites that provide processing power for the Large Hadron Collider. Sort of there's a lot of middleware that goes into making sure that there's kind of like a uniform access. And I think with Euro HPC, this is now actually also a very hot topic here, right? Because there's also, as in Euro HPC, there's a lot of effort going into federation. And so CVM-FS fits in very well here because it's a global file system, right? So I mean, it has this central source of software, and then wherever you mount it, kind of like it looks the same way, it updates, and basically it allows you to access the software the same way as on all your compute nodes. So right, and so basically all of this server infrastructure is the solution to this distributed denial of service attack, right? So because if you have like a big cluster that is doing that loads software on the fly, you put a proxy in front, right? And then you have different replications, like different copies of the whole software. So in the end, you can be very flexible in kind of like scaling the system to the sites. Right. And so just the terminology that we use, right, is the hierarchy of these caches is the stratum 0 is kind of like the origin of the repository. We call the owners of this repository the software librarians because they kind of like curate the content of the software that is being pushed to the repository. And then stratum 1s are kind of like these the copies of the repository. And they have they're basically a full copy, so it's kind of like independent. There's a lot of thought about having independence and federation in this system. And then you get towards having proxies, which kind of like just take load of these server if there's a site with a lot of worker nodes. And then the worker nodes themselves, I already mentioned that we do keep a disk cache on local disk, right? So it's the equivalent of downloading the software to your local disk. Here we basically just keep a cache of whatever you access on local disk. And then there's a system that cleans up the local disk cache when it goes over quota. And finally, if your system also has then this kernel page cache, which I'm sure you know. And this is kind of like also a very important component of this all to make it fast. And in the end, kind of like one of the things that I stress this is a bit for distributed batch computing is because then a lot of the time in distributed batch computing, you actually work with a warm cache, right? If your cluster is running 10,000 jobs of the same thing, then oftentimes you actually already work with the warm cache, and you basically don't really feel a lot of overhead. If you're a single user, you might more often get into this situation where actually a lot of these caches are cold, and then it's a little bit more noticeable to start up. And we are actually like thinking a little bit about how to speed it up, but that's for later. Right. Just a few numbers of CVM-FS at CERN. So here this continues to keep growing. So you can see here just kind of like the counted the number of files in slash CVM-FS for several repositories. Here you see the big LHC experiments. These are basically our biggest users, and they're fairly big. Unpack.cern.ch is a bit special. That's a container. That's for container distribution. I'll talk about this in a minute as well. And you can see that there is in the last few years, there's a continuous growth, but it has sped up a bit. I kind of like to think that this is because a lot of these machine learning frameworks, right? TensorFlow and all of these things, they tend to be quite heavy, right, in terms of the binaries that you need and how many files that you actually take when you do import TensorFlow and these things. All right. Before going in the technical details, just kind of like quickly wanted to show you how this looks like on a real life system. So LX Plus is kind of like a shared login cluster at CERN. It's an old school shared Unix machine. So it's basically being used for lightweight compute jobs. Like before people send things off to batch systems, maybe they will try this out on one of these machines here. And you can see that in CVM-FS, right, there's really already by default, you have a lot of repositories loaded. So that this includes LHC ones and then different other ones. Uh, you often have things like conDB, that means conditions databases. Sort of these are kind of like additional auxiliary files that get distributed with CVM-FS here. We have cvmfs-config.cern.ch that has configuration for CVM-FS. So we kind of like dog food CVM-FS by putting the configuration of CVM-FS itself on CVM-FS, and then lots of other things. And I think I can't show you too much here, but I think this is something I can do, right? So for all of these repositories, you can see how much they're being used. And so you can see that a bunch of these actually do have I'm pretty sure that there's a couple of users at the moment, right, which are loading stuff from CVM-FS. And it actually helps you, right? So sort of the admins of this cluster, then they don't have to separately install the software for all of these different experiments and repositories, right? But basically they can just say, okay, CVM-FS is available, and then if somebody wants to use Atlas software, then they can do it from here. And it's just the same setup for everything. Maybe I can also show you here. I think I had a dashboard for this, right? Sort of this is for the same cluster that we just saw. It's like one of these. I was just on one of these machines. It has a different kind of like different metrics to show a bit the health of this thing. An interesting one is this, right? This shows kind of like a bit the difference from the latest revision that was just published. So here there's lhcbdev.cern.ch is one repository that publishes a lot. So basically the LHCb experiment installs all of the pull requests there as part of a CI workflow for testing. And so they typically publish all the time, and then sort of this lags a bit behind. Sort of, and I think we'll talk a little bit more about monitoring and what you want for monitoring. So here in particular is nice also is one of the most important things as a takeaway for monitoring already is that it's nice to monitor the cache cleanups, right? Because if here you would get more than 20, let's say, right, one per hour, then most probably your local disk cache is too small, and then you keep trying to clean up things here from here. All right. Are there any questions so far? Otherwise, I think I'll just continue straight.
Not seen any question in the chat so
All
far.
right. Then
Maybe yes, one question, Valentin. We have a question on Slack.
yeah, let's go.
So the question says, how does CVM-FS ensure that the local disk cache is not out of date when accessing local cached file?
Yeah. So the local disk cache works the same way as the backend storage. It's a content addressed. It basically stores files in a content addressed manner, right? So if the anything that you store in the local disk cache, it's by definition it can't really go out of date, right? Because it doesn't like the files don't have like a lifetime tied to the current version of CVM-FS. If okay, if you think about if you would remove a file from CVM-FS, and that's still in the local disk cache, that's probably not going to be used anymore, but you don't need to update it, right? So it's not that the file has to that we have to keep the cache up to date because that's basically content addressed. What will happen is at one point as the cache grows, right, we trigger cleanup, and that typically will then just delete the least recently used files first, and then at one point, right, this gets cleared out. And if the file really isn't used anymore, then it's just gone from the cache. There is sometimes also the question about kind of like how the new versions propagate, right? And this typically it should be very simple. I mean, most of the time there's just a very small delay, and then the client that you just automatically see the new version. If there's an application that holds files open, right, it still sees the old version. Typically, what people will do is they won't change software versions on the fly for this reason. So in place, kind of like, right, so you won't overwrite your executable with a new version, but typically because you anyway install in kind of like an unusual location, right? Just install to /cvmfs, and you have some way of setting up the application environment. You typically just install in another directory here. Because if you don't access an old directory, right, sort of the version, but I think we can maybe that's also an interesting thing to see. So actually, how does this look like when when you do this? Like for our CERN repositories, a lot of the time people just use plain setup scripts. So I can do something like this, right? That sets up this. This is what we call the LCG release. This is kind of like a set of shared dependencies that are being used by a lot of experiments. And if I now check, right, uh, which Python there is, it's basically taking from this view, but if I check where this is actually coming from, right, it's installed in kind of like its own separate prefix, right? Sort of you have lots of Python versions here. If we check here, right, sort of they install lots of Python version, and typically it's fine because you don't actually download any of these different versions if I don't actively access them, right? So if I don't do Python, and we can check here, it's going to be no, it's actually quite fast, right? Sort of some things can typically be a bit slower. So, for example, Root is a very widely used analysis framework. This is, I think, slightly slower than when I'll do it here just to illustrate this point again. Okay, I didn't time it this time, but it tends to be like a bit faster, right? Just because then the cache is already working. Okay. Yeah, I think I'll maybe give a bit of an internal detail explanation of the cache a little bit later when we get to this to the demo. Then I think I'll then kind of like show how to set up a CVM-FS repository and then give kind of like a bit of the plumbing, the internal details of how that works. All right. Maybe also just to this slide can maybe explain a bit of a few of the terms that we tend to use. So, right, the client is really the software that installed on the worker node that allows you to access CVM-FS. And then our server tools, those are the tools that are then being used by someone to write to /CVM-FS to publish to the repository. And then in addition to this, there's a few tools that are about container publishing. I'll have a bit about this at the very end. And there's a component called the gateway that lets you have several publishers, right? That is kind of like the gateway to the backend storage and that lets several machines connect and write to a CVM-FS repository. Other utilities is kind of like the preloader lets you preload the cache with a certain software, and shrink-wrap lets you basically take like data out of a CVM-FS repository onto local disk, right? It takes a bit of a subset of the directory tree and then lets you copy this efficiently to local disk. It's a POSIX file system, so in principle you could also use rsync. It's just that this is a little bit more optimized. It keeps this deduplication of the object store. And then we have a few extras. CVM-FS exec is a tool that allows you to install CVM-FS when you don't have admin privileges. There's monitoring tools for when you run a Stratum 1. We have an action for GitHub Actions, right, where it installs CVM-FS and you can use this in CI workflows. This actually is a bit deprecated. We don't really have authenticated access with X509 certificates anymore, so it's a little bit outdated. And there's different types of monitoring that we have as well. All right. So, okay, now jumping into kind of like the configuration part. So, like, all right. So, hopefully, if you were just going to use CVM-FS on a machine where it's already there, it should need no introduction at all. So now we're getting into the part is how do we actually prepare a machine to allow people to access a CVM-FS repository. And this also should be fairly simple, although there's kind of like a few things to keep in mind. Its installations should be simple, and then the configuration is also almost automatic, except for like a few of these things that you need to do. And all of this, I think, also has a very nice tutorial on easy.io in the tutorial docs here, where you can read up on these things. So we have packages available for most for x86 and ARM and generally Debian and RHEL-based distros. In principle, macOS, I don't know if anybody uses it. In principle, it's possible. It's a bit complicated to use MacFuse on macOS. At the moment, like the most reliable way to use it requires installing kernel extension, which Apple makes more and more difficult. So that's a bit complicated, but in principle, that's possible here as well. So what we always advise to use is our CVM-FS release package that kind of like just installs the keys and sets up the RPM repository with our mirror servers. And in principle, that's kind of like all you need to do there. You can obviously also do this yourself, like on this URL, you also find the keys and then the information about the the RPM repos is in this release package, right? So in principle, you can also copy these things by hand. But the nice thing about this that it also keeps it up to date. And recently we added like another mirror server, right, to our package repository, and that then helps you just to automatically get new updates for this. We are interested at one point. It's kind of like in our to-do list, right? To actually package to get CVM-FS into upstream package repositories that you don't need to use our package repositories. We'll probably keep them, but I think that's very nice and convenient. It's a few historical things, kind of like the way that we bundle debug libraries as well in the packet, and a few dependencies that we vendor still. And that basically we're just trying to address slowly, and at one point that is going to happen, I'm pretty sure. But we have a small team, and all of this tends to take a little while. So in principle, this is then all you need to do for the installation. And the next step is then the configuration. And there's really lots of configuration parameters for all of the different extensions and various special things. Really, the most important ones is that what you need to have is the keys for a repository. So this allows you to check that the content is actually verified and what you expect it to be. So you basically want to only mount repositories where you trust the key. So for a lot of our repositories, we also put this on this cvm-fs-config.cern.ch repository. And if you're using EESSI, this is actually also present in our cvm-fs-config.cern.ch repository. Or you can install the EESSI actually also has a configuration package. Yeah, so this I think it's also in the tutorial how to get this and to install this in the instructions specific to EESSI. You will have this sort of the keys is kind of like the first step. And indeed, I think the configuration repository can be very convenient also, right? Like in an environment like the grid, it's kind of like very hard to get everyone to upgrade their configuration if you have something that everybody should update, right? And it's very easy to just tell everyone to mount this configuration repository, and then you push changes there. But indeed, actually, there's sometimes sort of we do have one open bug at least, which is in very rare circumstances, right? That you can have some problems reading from this config repository, and then obviously it's also nice to have kind of like the backup configuration on local disk. So it's not a bad point. Right. So I think then in the actual configuration parameters, we have a configuration system that is in principle very easy. It has a bash-like syntax, right? You just set these variables for different things, and typically you have a hierarchy of the configuration, right? If you have .local file overrides a .conf file that with the same name, and default is basically one of it applies to everything, right? And that's typically a good way to set things. If you have a configuration that's specific to a certain repository, right? For example, for EESSI, you can also set this to /etc cvm-fs config.d /software.eeessi.io.conf. That's how you would do it for a specific one. So the parameters that the only one parameter that you actually need to set, otherwise you won't be able to use CVM-FS, is the CVM-FS HTTP proxy one. That is kind of like a bit on design that we don't make this automatic. You can always set this to direct if you don't have a proxy, but we want to make sure that if you have a cluster, right, that you at least take this step and see if it actually makes sense to use a proxy, because in the end it does help a lot with the infrastructure to have proxies, and we'll come back to this a little bit. The other things that can be useful is the quota limit. So this is kind of like the soft limit for the CVM-FS local disk cache. This is really when you go over this quota limit, right, you will trigger a cleanup that will try to delete files back to half of this quota limit. That's the default behavior of our local disk cache. Now, it's there's sometimes a bit of confusion here because this quota limit really is soft, right? And also, if you know how the file systems work on Linux, right? If there's an application that's holding a file open, deleting that file won't actually free up disk space until the application closes it, right? So this is also sometimes the problem that if you have an application that holds open a lot of files, sometimes our cleanup just becomes a little ineffective because we try to unlink the files but they're being held open, and so they don't actually free up any disk space. Right. And then sometimes I think the default for the CVM-FS cache base is varlib CVM-FS. And sometimes you want to put this on different partition, different paths. Sort of that's a common one that you want to set as well. All right, for easy, it looks very similar, right? You can instead basically you install the easy config package, and then you can configure this. Client profile single is a very similar option that implies that kind of like you use direct, but it also tries to use, we have kind of like a Cloudflare poor man's proxy, kind of like for a single workstation, right? We use the free tier of Cloudflare to provide like a little bit of proxying, which works quite well since CVM-FS tends to not be very hungry in terms of downloads and resources. So that this is actually quite good. And yeah, then indeed, once you change the configuration, you have CVM-FS running, and you also need to do the CVM-FS config reload command. Right. So once you scale this beyond a handful of clients, right, there's a little bit more work to be done. In particular, it's here's the example of easy, right? So we've now actually managed to replicate easy on a bunch of different Stratum 1 servers, also in the UK. I think there's at RAL, there's now a copy of easy. And so this is good. But right, still once you have a bigger deployment of worker nodes using CVM-FS, the most important thing is really to set up these private proxies, right? In principle, I think you can get away with doing only a deployment of proxies if you trust the uptime of your closest Stratum 1. Once you get, I think, to a critical number of Stratum 1 servers, that tends to be that's typically the model that I think a lot of compute sites at CERN do, right? We have a few around Europe, and that tends to be good enough that even if one goes down, there's an automatic failover to the next one, and that handles this well enough. If you really want to have your data locally, which can also be a very good idea in some circumstances, right? You want to do a private Stratum 1, and you use the CVM-FS server tools that we'll talk about a little bit about in a minute. So, right. So for the proxy server, it's actually quite nice since the HTTP transport that we do is fairly simple, right? So I think you can use most forward proxies. The one that's the most battle tested, the most widely used, at least in our community, is Squid. We have also alternatives and looked into various things like Varnish, which is a reverse proxy by design, but you can make it behave like a forward proxy. The problem with running reverse proxies is often that you need to make sure that whatever you're pointing to, right, as behind the scenes doesn't get out of sync, right? As a forward proxy, we have our own fallback mechanism baked into the client, right? So in principle, that knows how to deal with a Stratum 1 that hasn't replicated yet and is a bit out of date and still waiting for updates. This can be a bit of a problem when you actually use reverse proxies. So we wouldn't recommend it right now. We are looking into ways how that makes it better to use. And I think I haven't published this yet, but a colleague of mine has also looked into using Apache Traffic Server for CVM-FS that works quite well. In principle, the main difficulty with Squid is that historically in high energy physics, these proxies have also been used with a distributed database called Frontier, which is a little bit trickier to cache than CVM-FS. So our Squid configuration can be quite complicated because of Frontier, but I think the CVM-FS part is actually quite simple. Right. And for Stratum ones, you typically make use the CVM-FS tools to manage them. So they're full copy of the content of selected CernVM-FS repositories, and you can actually turn them again in a Stratum 0. So so in principle, if you have full ownership of the software that is being published there, and in principle you could kind of like stop synchronizing with an upstream Stratum 0 and start publishing software yourself to this thing. In practice, how this is being handled is that as most of the time this is really just done as a cron job that like every 5 minutes or so you will check if there's news from the Stratum 0. There's a very quick operation, and then if there is, you take the snapshot and pull in the new files. The easy the number is actually of the repository. And this is, I think, from last year. So I'm guessing that now it's around 500, 600 gigabytes, something like this. Indeed, this is really not that big yet. I think I can show also the data from a few repositories at CERN, right? So in CERN we use Ceph-S3 as backend storage for these repositories. I have Atlas and CVM-FS and CMS, one of the biggest experiments and users of CVM-FS, and you can see that here there are beyond 12 terabyte. Here Atlas a bit smaller at around 6, but this is kind of like growing steadily, and so far hasn't really made any bigger problem. The funny curve here, that's actually our container repository. So you can see here that this has had a big growth, right? And at one point, we've never really done any cleanup on it. So here you see the effect, right? I think we're going to talk about deleting stuff from CVM-FS still. But at one point, we actually started to do like improvements also to the container distribution to make it smaller and do some extra cleanup of outdated images. And then this went down. But you can see that this is actually still quite big, and especially the only thing that actually made problems here, where IT told us, okay, like here we need to do something, is really because the number of objects grew so much. At one point with S3, with Ceph-S3, you have to do an operation called index resharding, and that actually really then starts to be a bit problematic if a repository grows too fast. So in principle, the message I think here is that this can scale quite well. All right. Further questions so far. Let's bring this up again.
Yes, we had a question. One question was, are there any packages that put pressure on the 10 gigabytes quota? For example, PETSI or genome database or something similar?
Which 10 gigabyte for the local disk cache?
Yes.
What do you mean pressure?
Do you know any of these packages that, let's say, could exceed the quota limit easily?
You mean okay? So one complication I know of is that you shouldn't use /tmp for this local disk cache. What you don't really want to do is have an additional cleanup mechanism that deletes stuff from the local disk cache. So that in the end leads to basically just an IO error, because CVM-FS is trying to read a file from the local disk cache that was cleaned up by an external cleanup process. So that that is one way to make problems. But did you mean just kind of like I'm not familiar with the packages you mentioned. Are those just kind of like really large packages that you expect to give problems when you read them on from CVM-FS?
Yeah, so I think you explained that these files are kept open when
Yeah.
right when they're in the cache. So if an application holds the file open, and there are maybe many files or large files, and they're all kept open, it could result in that you exceed the cache, particularly when you're on a shared node, right, where you have many applications running.
Yeah, I think in practice it's not such a big deal if the cache is big enough, right? I mean, so the basic problem is, right, if you load 4 GB of software, right, you need to have disk space for of 4 GB, right? There's no real way around this. I mean, that's you can actually CVMFS works better that way because I mean you already start to delete stuff, but and some of the things might only then be kept somewhere else. But okay, sort of this is the hard limitation, right? That we need to have enough disk space for whatever is actually being read by the applications.
Yeah.
I mean, and it's true, like kind of like the experiment software that we use in high energy physics tends to be pretty big. So here we kind of like typically count that one experiment, right, one user that runs like really a heavy workload with one experiment software uses about 4 GB of this quota limit. Uh, but that in principle, um, I think the you can still kind of like get around like some usage spikes just by kind of like having a little bit space in reserve, right? So if you have this on a partition that is in principle big enough, and most of the times you're lucky that it's not completely used, and that you actually get away with kind of like usage spikes, let's see.
Yeah. So maybe that, as you mentioned, that this quota limit should be is a soft limiter, and it should be just something to see as when the cleanup kicks in.
Right.
Yeah.
So typically, I think like it's always good to kind of like not set this too low. At least make sure that the partition has enough space. You can actually set it a bit lower than you would think you would do it, but make sure that the partition has enough space for exactly this reason, and then check exactly this cleanup parameter in the monitoring. Right, if you see that you clean up several times per hour, it's likely that it's just too small.
Yeah. And then I guess it depends really also on the software package, but also on the site where it is used. If there are many users having different jobs, needing different software packages at the same time on the same node, then maybe you have to have a larger cache.
Yeah, depends a lot on the use case, right? On how many on the size of the node as well, right? We've seen that kind of like the compute nodes have grown a lot in the last 5, 10 years, right? So that is also something where sometimes our default configuration hasn't kept up. And we actually we have a project for this year where we try to make sure that it grows a bit. It scales kind of like with the node. If it's a 512 core nodes or some crazy machine like this, right? That you actually already have default values for this configuration that are a bit bigger than if it's just a small flavor virtual machine.
Okay. Thanks for the answer.
All right. Okay. So time is flying. I think I do want to mention a few more things, right? I think I'm not going to show in detail how to set up this quit, but this is kind of like in principle the basic configuration. You have this all of this on the tutorial as well. I do think that I want to to show you quickly, just in a hands-on way to how to set up your own Stratum 1 mirror, like Stratum 1 server, like basically actually no, the Stratum 0, because I think we're running out of time. So I'll skip a bit here and just show you like a few of the things that you'd want to do. So here I think we only have the Stratum 1 and this the alternative access mechanism. So actually, right. So what I'll do is just to take another node. This is kind of like a test VM that I have. It's an Alma Linux 9 node, and I very quickly want to show from the documentation, right, how we would install a repository, and then just kind of like want to show you a bit the basic ideas of kind of like the things that happen behind the scenes when you use CVM-FS. Right. So we install here the latest version. One thing that I want to point out is that we have so if this is the package configuration that gets installed here. Hoping that it's big enough. Yeah. And one thing also that we do have, basically this is the configuration with our package servers. This is the key file that gets installed by the release package. And we then do have testing and future packages. Like the testing is really just you get the production release typically 1 or 2 weeks early. And the future is really pre-releases, right? So we tag, we already have 2.14.34 tagged, I think, right? And this is in testing on various machines. So if you have something like a QA fraction of your cluster, it's very much encouraged to at least use like have a few of them update from CernVM testing, because that also you also have more confidence, right? And when you update, that there's no problem. In principle, there is a very comprehensive testing, but I think that's always a good recommendation here. All right. So I do want to first set up my okay. The first thing is just kind of like maybe to show again the thing about mounting easy, for example. So for this, the one required parameter is the CMFS HTTP proxy, which is direct, since we don't need it here. And then I have CMFS config set up to set up AutoFS. And then in principle, I should be able to right. So is we had you can see that this is kind of like AutoFS in action. It's also something that is sometimes confusing, right? Because /cvmfs was empty, but actually then there's a file system being mounted automatically when you do the directory access here. And in principle, you should also be able to do software. Right. So okay, you can see that this is then happening on the fly, and that in principle is very easy. Now I'm going to turn off AutoFS for a moment and show you how to make your own test repository. This is done with the CVM-FS server tools, and the command here to use is mkfs. So I will go test.repo.org. All right, because I didn't install a CVM-FS server yet. So let's do that. Right. So actually, one thing that I just wanted to mention before, so the one different, like, okay, I mentioned that this is then basically a POSIX file system, right? So it's just regular files, and they have this magic that they get downloaded on the fly. The one thing that we do add on top of the file system, which sometimes can be quite interesting, is that we do extended attributes, right? So do we have, yeah. So you can check that with this utter command, right, that breeds attributes from files. We have kind of like a lot of information that is CVMFS specific, then you can get just without any tooling at all, right? Sort of this is really just kind of like additional information that the files already have, and you don't need CVMFS tooling to do this. And for example, uh, the thing uh, that I was mentioning, right, is that is very useful is this ncleanup 24. Sort of this is 0. If I do cvmfs config wipe cache, it's the command, right? Sort of then, whoop, uh, all right, because this actually then because it really wipes the cache. Like I always get confused about this. I think what I'd have to do is there's another command, which is this maybe also good to introduce it to. It's CVMFS talk. This is an admin command, right? So it actually talks to the CVMFS process via a shared pipe or a socket. And here, what I can do is so that this has I think a bunch of useful things that are all in the documentation. But okay, if I want to say the to give this example again of the cleanup, then I can do software.easy.io cleanup 0. Okay, and now if I get it right, now it had a cleanup here on this thing. Okay. This is just is I think something that is quite useful, and we try also to add stuff to these extended attributes. And if you have additional information that you would like to see here, typically tends to be the easiest way to get information about CVMFS, because you don't actually really need any tooling. So it also works, for example, in a container where you bind mount CVMFS inside to the container. All right. Then just very quickly to let me stop again AutoFS uh, and start Apache. This we typically need to do. And then I can create my own software repository. It's called this test.repo.org. It's owned by the root users, right? And so it gives me all of this information and says, okay, the main thing is that it created new keys that are being used to sign this repository. And if I wanted to mount it from a client, actually I also need to give them these keys in order they can verify the repository content. Now, the actual data for this repository is by default in /serve CVMFS, right? And sort of here's the test.repo.org. And you can see there's a few special files here. The most important one is this .cvmfs published. This is kind of what we call the manifest of the repository, and it just is kind of like the entry point of the repository. So it's a very simple file that has like a few fields of text and a signature. It says basically the name is test.repo.org. It's not garbage collected. This is the first revision, and interesting, like the one of the most important parameter is I think this one is the hash of the root catalog. So basically, all of the actual data files are here under data, and this is then basically D4 should be D4. Let me see. Oh, no, it's not the D4. So maybe I got the wrong one here. Uh, Let me check where are the. This is small enough that you can do a recursive listing, basically. Uh, all right, so here is the DC4. So right, so here you can basically see all of the things that we store. This has a capital C appended to show it's a catalog. So I think that I got wrong. This. Huh. Okay, I don't know why. Ah, DC4 here. Oh, right. This is the field. Well, R, I think it's a different one. I think I was trying to look for this one. So this is the what we call catalogs are basically is the metadata of all of the files because we place them right just in a content addressed way, so you have no idea how the file name, what actually the file name or any of the information that you typically want from a file, like how it was modified and anything else. So you really don't know how this is going to be called. And so this backend storage, it's really the server is very simple. It basically serves everything in CMFS tested-report.org over HTTP. So I can also basically do that. That should be the same as doing this. This. Let's see if this works. Host CVMFS test.report.org. Let's do like this. I don't remember the option. Localhost with a typo. Minus O like this. Right. Okay. So you see, you get basically the same thing. All of the things here are really served from backend storage. A lot of the time, you actually also use S3 for this, and it really works completely the same way. You place things in this content addressed way, and then you see things. Sort of then the way to publish to things like here we have uh, the way that is most typically used is that here we have on /cvmfs now test.report.org, and that's an overlay, right? If you take a look here, there is an overlay of test.report.org that is basically the lower there is a CVMFS mount. Sort of this is just kind of like in bar spool. CVMFS is our directory that is used for kind of like publication operations. And the upper there is a scratch directory where files are getting written when I write to this overlay. Right. So when basically what happens if I do a publication. Now first it's transaction. Then this becomes writable. So test.report.org, and I can kind of like do just write anything to a test file here. And then this test file should show up here in the lower there, upper there, I mean, yeah. So let's take a look here. Right, so you have the test file here. And then I can do the publication, which basically takes all of the things in this scratch directory and creates the catalogs, places them into the backend storage, and does all of the other things. Server publish. Right. And so now this is then basically there, but it's no longer in the overlay, right? So it's kind of like moved from here to slash serve CVMFS. And when we take a look again at the at this now we're at revision 2, and also this catalog has changed, right? Because now it contains the metadata also of this test file. And What you can also see in this vars pool CVM-FS directory, this is kind of like a normal CVM-FS client mount. So here it's kind of like this is the same repository content, right? This is what's being shown also in as part of the overlay on /cvmfs. And in the cache, we should also be able to see now the same directory structure that we had before. There's a few additional log files and things like this. But if we take a look, let's see if we get lucky to find this. There shouldn't be too many files here. This one. Let's see. Yeah, this looks like it could be it. Right. So in the cache, files are already uncompressed. Okay. So if this is then actually okay, I didn't find my test file, but this is the default test file that we place here in these test.repo.org things. So it's this one, right? So if this corresponds to basically this file here, it's already decompressed, and the hash is actually for the compressed one, right? So here, right, if we go sort of this won't match, right? But in the backend storage, this is actually stored in a decompressed way. So here, I'm guessing that this would work. Data, and then we have 9. Right, so this file, in principle, we should be able first right. So what we can do is to uncompress this. We have a kind of like a bit of a special command for this set pipe -d. You could also use the basically any kind of unzip command, right? There's I think there's a command for zlib that lets you decompress files. It's just zlib compressed in principle. Okay, so you can see that this is the same thing, and just for the demonstration that this then also corresponds to the hash of the right. So here you can see that this is then actually also matching this way. So if this is basically then the plumbing of CVM-FS, it can be quite useful at least to know sort of one thing that typically makes sense because the CVM-FS client is doing the very same thing, right? Is to know that you should always be able to access this .cvm-fs published file. So, right, so if you're trying to configure CVM-FS and you have a problem with the server URL, typically you also won't be able to do this type of curl, right? If this URL is not working, that's kind of like the first indication that something is wrong. All right. Any questions towards the internal workings of CVM-FS so far?
See no further questions.
Okay, then I think we're getting towards the end of this. I think I want to briefly mention kind of like these additional access mechanism to CVM-FS. So most of this, ideally, I'm always hoping that you know a site manages to install CVM-FS in some way. It can be a bit more challenging if that's not possible for one or further reason. It's always a bit of a trade-off and workaround in some sense if you don't have this installed. But okay, there's a few things that we can do. This is just also in our like in high energy physics. Also, people have to use HPC systems. Actually, so like some of the time The pledge that comes with a CERN membership, right, includes computing resources, and sometimes it's just part of a HPC allocation, and is often at times very complicated, right? So ideally, this is the model, right? That the grid model, kind of like it's you just have CVM-FS and that with internet connection that runs. If there's limitations on internet, local disk, or kind of like just the willingness of the admins to install CVM-FS, then it can become like a lot more difficult. And experiments sometimes have done like very complicated things to trace the application file access to CVM-FS to build kind of like an offline package from CVM-FS and submit this to here. So the tools that we have is CVM-FS shrink wrap, which is kind of like rsync, but a bit more efficient as it keeps the deduplication that we have in this backend store. It basically copies the backend store and then does symlinks to the backend store, but you still get kind of like a local directory with all of the files. We are in the process. I think if you've been following the discussions around EESSI, we want to be able to have partial stratum ones, right? That you have a partial, like a stratum one that has a complete copy, but maybe only for x86, the x86 binaries of a CVM-FS repository. And so here we're actually in the process of rewriting shrink wrap to work a bit like the partial stratum one, so that you use the same code path. It's a bit of an internal improvement, there's a lot of ongoing work on this in some way, because I think that somehow makes sense, and in the end, it's a very nice and powerful tooling that you can kind of like have this stuff offline, that you can actually still make it into a stratum one and all of these things. So if you have no local disk, there's few options that you have. Loopback file systems can be a good idea, because if it's a cluster file system, right, it takes the load off the metadata servers. We tend to have lots of small files, and that really has shown to work much better on different cluster file systems. There is the possibility to go more complicated and use like part of a RAM disk, right? And like can have kind of like a tiered cache that tries to use kind of like a very small cache in RAM, and then other caches as you have. We do have a few more historical things as well, so don't get confused when you look at our documentation. There's NFS exports and connectors to Parrot as well, but we don't really recommend these anymore. CVM-FS exec is the tool for when you have no admin privileges, but you want to access CVM-FS. It's not super. It works very well. It's not super straightforward on the first glance, because it has 4 different modes, and depending on kind of like what you have available on the host, which features, which kernel version you have, it uses different things, but it actually turns out to work quite well. The main downside of this thing is that you have no shared cache on the system, right? Because this is running unprivileged in the home directory of some users. So if 2 users are actually accessing EESSI at the same time, you don't get any of the benefit of having this system of a shared cache. Since time is moving on, I don't think I'll be doing any kind of demo. Just quickly then talk still about monitoring and troubleshooting. We do have, right, I was mentioning already a bunch of these things in kind of like the hands-on thing. There's the CVM-FS talk command, which does need admin access, but gives you kind of like a lot of internal metrics, and it also allows you to post commands to the CVM-FS process, right? So you can actually force a cleanup and check this. The cache cleanups, it's probably the most interesting one, and the current revision, right? So there's a few more obscure issues, right? So if you have problems with the cache and you cannot load any new catalogs, then it can also happen that the CVM-FS mount gets out of sync. This is typically the only failure mode that I know of, is right if the cache is kind of like the repo, the partition is full, and you cannot load the new data as it comes in from the stratum one, then it might get out of sync. And otherwise, typically there's also a time to live of I think typically it's 2 minutes or something like this, where the client just always checks if the manifest, this .cvmfs published file that we just saw is up to date. Right. Then for monitoring, we have a few different solutions. There is a Nagios plugin, right? That's a bit very basic in some sense, but lets you give a few health checks, let's say. For if you run a Stratum 1, there's the CERN-FS Server 1 package, but it's actually fairly specialized. This is correct. D actually there's an influx plugin, and actually I think I need to update this slide because there is also a new way to. We also have by now a Prometheus plugin, so I think I should be able to do. But I think I need to look up actually how that was called. So that's yeah, let's see. Sort of this is this package. It's fairly new, just from last year. So we have a Prometheus CVMFS exporter that's also fairly nice. In principle, it should just you just should need to do this. Uh, right, sort of this is running, and see if I can get easy to run again. Yeah, and now let's check. I think this was the part that we have reserved for CMFS, right? Okay, and now you can see that here this metric exporter is giving you a lot of things. Most of them you actually find also from the etc. Maybe actually this is a bit too detailed. I think we went overboard a bit with some of these things. Right, sort of anything here. These are all internal data structures, which can be interesting to really tune these things, right? But you have kind of like a lot of interesting information, right? It shows you the proxies that are being used, the number of cleanup, like all of these things. So I think that's quite nice. And we do have like an ongoing project as well to get an example Grafana dashboard to be used with this. So I think in terms of monitoring, this is kind of like the most recommended thing, even if we might get put in another version that shows a few less of these very detailed metrics. But I think it's in principle is nice, right? Like it orders them according to different things for the cache, right? For the network, how many, like all of these things. So I think that gives you as an admin a very good view of what's happening here. Right. Ah, sorry, my Zoom commands are getting into the way of this thing. Let me just. All right. Anyway, I think I can. Getting towards the. No, no, I can do it. Here we go. All right, and finally, troubleshooting. It's This is one thing where CVMFS can be a bit obscure, mainly because, right, I mean, the big benefit of CVMFS is that it's a POSIX file system. But the drawback is also it's a POSIX file system, right? So in principle, you cannot really show any custom error messages to the user because all you have is kind of like you're limited to returning an error code, right? You can give an IO error or whatever for if your application tries to access CVMFS. For anything else, we need to kind of like use the syslog. So good places to start is kind of like checking the configuration with show config. CVMFS talk has also a command called parameters, which so config shows kind of like the config as it is on disk. CVM-FS talk parameters shows the config as a CVM-FS process has loaded it from disk because it could have changed in the meantime. Maybe need to reload. There's this probe. And then there's this also the CVM-FS config stat command that shows kind of like the current connection and the thing. And typically you also want to look into the syslog because that's mainly there. When you do get errors, kind of like just accessing, there's a few different things that you can get. Sort of there's one thing that sometimes pops up is too many levels of symbolic links. And that's typically when you try to access a mount point without this kind of like shared options for namespaces, right? So in a container, you actually need to use this -v. If you bind mount CVM-FS into a container, you need to do this. Here's a colon missing, but in principle, you need to do this CVM-FS shared because otherwise, and this kind of like triggers kind of like the file system to report this error. Right. So if you can't find a path that you'd expect to be there, it's the only thing that I think I've mentioned this already. The only way that well, we know that this can happen is right if you cannot load the new metadata onto the local disk cache, and this again should kind of like give some error message in the syslog. Software caused connection abort. This is kind of like typically when a fuse thing, when this has been cut by the kernel. It only typically happens when the admins really kill the fuse connection themselves. It isn't typically something that happens otherwise, but what you need to do here is basically to remount. Transport endpoint is not connected is something that comes up a little bit more often. So, for example, if you have a node with out of memory conditions, right, and the CVM-FS2 process has died, typically what you need to do is to unmount and remount this repository as it's a file system mount. And we have a functionality in CVM-FS that is called the watchdog process, which watches the main CVM-FS process and tries to do this automatically. But in this scenario, it didn't manage. Sometimes, depending on how you configure your cleanup, it can take down the watchdog process too. And then this is kind of like a scenario where you basically need to manually unmount and remount. Okay, I think that basically brings me to the end of what I wanted to show today. We do have a little bit of kind of like a few plots of software startup performance, and then I have a very small demo also on how you would use CVM-FS with containers. But I'm going to check first if there's any questions.
I don't see any additional questions.
Okay, but I think we still have it's taking longer than I expected, but I think we still have 5 minutes, right? And I will quickly show still the performance and the container parts. So right, so I've mentioned before that one of the worst cases for CVM-FS is a package like TensorFlow that really loads a lot of small files and actually takes 1 GB of data to load it. It's a bit bad, and you can see that it actually even on a RAM disk, right, it takes 2 seconds to load, and on local SSD, it takes even loader. But then if you populate the kernel page cache, it's around 2 seconds. NFS, it's a bit worse on a cold cache, also not too bad. And here it starts to get really bad, right? GPFS and Luster, they tend to struggle with small files, and then you get to numbers like this, right, where you're waiting for 30 seconds to a minute to load files. Now, how does the CVM-FS get here, right? In principle, it depends a lot on the network connection, right? So if you have if you talk directly to the on a cold cache directly to the to the US from Europe, then it's going to be catastrophic, right? It's already okay-ish when you have to load it from a cold cache from within the EU. And then if this basically the next stratum one is close, you get even better. And then really once you have the warm caches, you get really close to the actual native performance once the cache is warmed up. So I think in terms of performance, this is actually quite nice. And we do have like an upcoming feature also in the next version of CVM-FS where you can basically tell CVM-FS which files are going to get loaded when you do import TensorFlow, and then it's going to start preloading these files essentially. So it's the file bundle feature. And then for container images, a very quick demo here as well. Here I'll go here. I've mentioned this unpack.cern.ch repository, and what we can do here with CVM-FS is basically let's take this one. Right. So here, basically, what we do is we store container images on CERN unpacked. So let's take one of these Ubuntu images here, and then you see that basically what you store here is really the root file system on the container, as you would see it once you actually start up your container engine and it overlays all of the layers. And what it's very nice because tools like Aptena. They really allow you to take this root file system and then run 20. Right. So they really, and you see that the startup here is basically immediate because I haven't really downloaded anything of the container image yet, but I'm here inside this thing. So in principle, I know that EESSI kind of like uses a very different approach to using containers. So I'll keep all of this fairly short, but it's just the kind of like to mention that there is tooling to kind of like distribute containers a bit like this. And I think this is actually all I will have here. So maybe that this is a very short demo if this actually loads. Let's see. Sorry. And I think I'll need to. Let's see. Right. So here basically it's just shows the comparison of like downloading basically pulling a complete image, right? Complete images where you have where you download kind of like the whole thing. And this is then the files that you save on local cache, right? And you basically need to load the whole thing. And the button here for comparison then will be the same thing as we loaded from CVM-FS, and it shows basically the CVM-FS cache. Um, so here, what I'm doing is to remove again this thing, and I'm using containerd, which allows us to do this for the images. Remove the image again, and now I'll pull it again while using the CVM-FS snapshot. This is a functionality in containerd that lets us give alternative sources for layers to pull from, right? And so I'll do the same thing again. And here, see, it's basically immediate. We haven't really loaded anything yet, but it's the same principle as with the on-demand download that you do it, right? So what I'm going to do next is here to actually access something in the file. This, of course, it takes a little bit longer, right? So what I'm going to start to do is kind of like then pull in files as they right. And so here, so once I'm actually starting to do something inside this, that is actually when we do work and we load stuff into the CVM-FS cache. But all in all, that also if you kept an eye on kind of like the total amount of bytes downloaded here, It's really much less than pulling the full image. Okay, and I think that brings me to the end. Yeah. Uh, I think like just I'm going to mention this very quickly since we already been talking for a while. So most of the times, all of these server commands still require either overlay FS or systemd, which makes it a bit awkward to use with containers. We've slowly been trying to get rid of this and already use containerized deployments for testing. And in the future, I think we'll almost also have Helm charts for this type of configuration if you wish to do it. We do have a working varnish cache configuration already on our CMFS contrib GitHub organization. I've mentioned this problem with having load balancers and reverse proxy together uh, with um, with Stratum ones. I haven't really mentioned the gateway so much, but this is something that we'll want to address in kind here actually that you have a high availability setup also in this gateway component that lets you have multiple publishers, so you don't rely on one gateway being up all the time if you need to have high availability for publishing. The file bundles actually are already there as a prototype, and we'll have that released in June. I've mentioned this already. Same for the partial Stratum 1 replication that I've briefly mentioned as well. And with this, thanks a lot, in particular to also all the easy folks who contributed to this tutorial. I hope that was interesting. We do have quite a few contacts. I think the easiest is obviously through the EESSI Slack, but here you can find as well. These slides will go up on the uh, on the on the webinar page as well. So you and on the easy documentation, so you'll be able to find this again. Feel free to contact us through any of these channels if there are any questions.
Okay. Thanks a lot, Valentin. There was a lot of material. Remind me a little bit about the first webinar we did together about 3.5 years ago or so, where it was almost like 3 hours or so.
Yeah, indeed.
But
I
now,
was thinking that it would take less time since I'm just alone today. But in the end, there's a lot of stuff to talk about, right? So it does take a
yeah,
while.
yeah. So let's say I think maybe we check if there are other questions. Yes, there's one on Slack. I can just read it if I want. To internally distribute software, say for license reasons, I would need a Stratum 0 server and a Stratum 1 server for it, if I got it right. How different is the setup between Stratum 0 and Stratum 1? Or is there something I don't get?
Right. So if you have just one site, in principle, you can get away with having just a Stratum 0 server. The Stratum 1, really, you want to kind of like have in more distributed environments, right? So you have one compute center in the US, one in Europe, right? Then it makes sense to kind of like have this distributed type of setup. For licensed software, it's a bit tricky, unfortunately. The model of CVMFS is very strongly that everything is public, right? It's plain HTTP, which doesn't really let you and also the X509 authentication we had is basically deprecated. There was only one major user of this, just LIGO Virgo, the gravitational wave interferometers, and there were kind of like a few problems with this, and it was hard to debug. So in the end, we basically decided that we couldn't support it. We are still thinking about other ways to distribute this. Like one possible idea could be to just encrypt the files on CVMFS, right? That you distribute the keys to the client which you want to read them. There's a little bit of overhead with the decryption then when you place this in the cache. In principle, that could be a nice way. And maybe there's also with token nowadays, there's also alternatives. Right. So The setup of the Stratum 1 is actually in this tutorial, so do kind of like basically check the slides and the things to go through the setup. In principle, it's possible to do. Also on the note that it's HTTP. In principle, we can do HTTPS. For internal reasons, it's actually very easy if you do S3, but if you run your own server from backend storage, it tends to be a little bit more complicated. But HTTPS is in principle also possible. Did that answer your question?
I think that was a good answer. Of course, I know that I think formerly Compute Canada, they have also licensed software and they just limit access via IP addresses.
Yeah, that's a way to do it via the server configuration. At CERN, we have the same thing, and here we just limit it to the network, right? Yeah, similar thing. So you have an IP range that just corresponds to the internal network, and only that you're restricted access by that.
Yeah. Maybe one other reason to have a Stratum 1 could be that you have a backup of the server, right? If your Stratum 0 goes down, so
Yeah.
quickly use that as Stratum sort of to how to say this, to make you out of your Stratum 1 or Stratum 0, that could be one way.
Exactly. It's actually like in principle you can also like write if you have this on a local like the backend storage, right? You can do backups of this and somehow restore them to a new machine, but it's I guess it's typically tends to be even easier when you have a Stratum 1 since you already have the whole thing set up. So this is indeed a good reason to have a Stratum 1 as well.
Okay, thanks. I see that Julian has raised his hand, so if you don't mind being recorded, then just unmute yourself and ask a question.
Okay, thank you, Thomas. My question is regarding the client installation. Is there a RISC-V package available?
Good question. No, I think we had in the past actually already a RISC-V build. Because we didn't have any hardware to do this, we kind of like discontinued this. But I think it shouldn't be too much of a problem today with emulators to have a RISC-V package. So it's basically it was waiting a bit for the to see if there's demand. But in principle, I'm happy to provide one. I can only test with emulators. That's the caveat, kind of to check the packages.
Okay, cool. Thank you.
All right. If you leave a note on the forum or a GitHub issue, then I can follow up on this and I don't forget.
Okay, and if you want, I can be a tester for the package.
Yeah, excellent. I think
It
that
would be great.
that would be great. Yeah.
Okay, thank you.
Okay. Other questions, comments? Okay, I see a question in the chat. Unless the Stratum 1 supported, so Stratum 0, Stratum 1, another Stratum 1 proxy client, so this sort of hierarchy of Stratum 1 servers?
That's a good question. In principle, there's no reason why you couldn't do it. So we do have kind of like a file that declares a server to be a Stratum 1. And I think there may be a check that you're actually replicating from no, but I don't think so. I think because I think the setup that we have is exactly this, right? That if there's a Stratum 0 in Europe, right, and several Stratum 1s in the US, I think a lot of the time there's only one Stratum 1 in the US that kind of like syncs from Europe, and the rest of them would sync from the local one. So indeed, I think that's supported. I'm 90% sure. In principle, there's also no fundamental reason why you couldn't do this. So in principle, it should be a fairly simple change to do it. But it's a good question. Yeah, I think it makes a lot of sense in some scenarios.
If I'm not completely mistaken, I think we have something like that already in place for EESSI. We have a special Stratum 1 dedicated for those who want to set up a private Stratum 1. And they should sync from this special Stratum 1 server.
Right.
Other questions?
Maybe I can add a question. So earlier, the question we had on Slack, maybe I can re-clarify it. So what if, for example, I am accessing a software and it's in the client cache, but on Stratum Zero it has changed. So how and when would I see the changes reflected on the software that I'm accessing or the files that I'm accessing?
Right. So that's a good question. In principle, what happens is like on the worker node, the client like this manifest that basically defines the current version of the repository has a time to live. And so there's typically 2 minutes, and after 2 minutes, if there's a new access to CVM-FS, it rechecks basically against the server URL, which to if there's a new manifest. And now there is also the proxy in between, and also the proxy typically has a similar time to live for the manifest. So in principle, it won't always go to the Stratum 1, but if you have like a lot of clients, also they typically this request stops at the proxy if the manifest as the proxy has cached is new enough, let's say. Right. So then kind of like once if this is outdated actually, and there's a new one on the Stratum 1, then actually this gets loaded, and really the it's just like very magically that the file system shows the new files that have been published. If an application has something that is already that is held open, it's going to be the same thing, right? So in principle, if you load something from revision 1 and then you change the file in revision 2, it won't affect a running application unless that kind of like rereads parts of the file. But in principle, that's what I said. Like in principle, like but okay, it's the same if you would do a local package installation, right? If you overwrite files, then you do have to kind of like make sure that the application that reads them, if it's running, that this is happening in a consistent way. I'm hoping that answers this. And one like okay, so typically people also want to know like what is then the end-to-end latency. Sort of this is then basically you publish, right? And then there is the latency of doing the snapshot to the closest Stratum 1, which typically tends to be around 5 to 10 minutes. And then you have this 5 minutes, let's say, until the time to live of the manifest expires. So the rule of thumb is that if you publish something, right, within 10 minutes, any healthy client should see it.
Thank you, Valentin.
Okay, there's a new question in the chat. Can you have multiple Stratum 1s, for example, per site in high availability?
Yes. There is an existing package that does this. Let me. Oop. So this is also here. So this is this have a high availability Stratum 1 pair of machines. That's kind of like a custom thing, like a set of scripts that manages two Stratum 1s to make them in a kind of like a high availability configuration. If you have questions here, this is managed by Dave Dykstra from Fermilab, who has a lot of experience in managing CVM-FS infrastructure for CERN. I think that's obviously very good to ask. In principle, as I mentioned, also I think to me it makes sense to have also like plain load balancers available. The problem here is always right that the load balancer needs to be aware of the differences in replication, right? If there's one stratum one which is lagging behind doing a snapshot, and then kind of like you do want to have this. But in principle, like the client has a built-in failover, right? So in principle, also you don't need to do anything special, even though this thing might help. But you can have two stratum ones if you have the resources, right? Then basically you can basically just give both as in the CVM-FS server URL and the client configuration, and the client will automatically fail over between all of the. It tries to use as efficiently as possible as failovers all of the existing servers.
Thank you. Are there more questions? 3, 2, 1. No questions anymore. Okay, thanks a lot again, Valentin. I think maybe we stop the recording just in case there's any question who doesn't want to be recorded. So if Richard also stops the recording.